E-Maths class, Fatima Convent High School, Chapter 6, Triangles, Standard 10. Working with exercise 6.2. Exercise 6.2 is based on the concept of theorem 6.1 and 6.2. We already understood in the theorem 6.1 that if a line is drawn parallel to one side of a triangle to intersect other two sides in distinct points, the other two sides are divided in same ratio. That is, if a triangle ABC DE is parallel to BC, then AD upon BD is equal to AE upon EC. And the converse of this theorem 6.2 is also true. That is, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. We are going to understand the exercise based on this. Exercise 6.2. Question 1. We have a triangle ABC where DE line is parallel to BC. Now we have to find EC. So, according to the theorem, we know that in triangle ABC, if DE is parallel to BC, therefore AD upon BD is equal to AE upon EC. So, 1.5 upon 3 is equal to 1 upon CE. Therefore, CE is equal to 3 into 1 upon 1.5. Therefore, CE is equal to 2. Same way, next question is similar to it, where you are supposed to find AD. So, in triangle ABC, BE is parallel to BC. Therefore, AD upon BD is equal to AE upon CE. Therefore, AD upon 7.2 is equal to 1.8 upon 5.4. Therefore, AD is equal to 18 into 72 into 10 upon 54 into 10 into 10 for simplification. We get the answer 2.4. Now question number 2. In question number 2, we are using converse of theorem 6.1, that is theorem 6.2. We are supposed to check if the given line is parallel to the side opposite to it. For that, in triangle PQR, PR and QR are having points E and F respectively. If we have to prove EF parallel to QR, we need to prove the ratio of the segments equal. For the first case, PE upon EQ is equal to 3.9 upon 3, that is 13 upon 10, and PF upon FR is equal to 3.6 upon 2.4 is equal to 15 upon 10. Therefore, PE upon EQ is not equal to PF upon FR. Therefore, EF is not parallel to QR. Second, PE upon QE is equal to 4 upon 4.5 is equal to 40 upon 45 is equal to 8 upon 9. PF upon RF is equal to 8 upon 9. Now both the ratios are equal and therefore EF is parallel to QR. In third case, PE upon PQ is equal to 0.18 is upon 1.28 is equal to 0.14, and PF upon PR is equal to 0.36 upon 2.56 is equal to 0.14. Therefore, PE upon PQ is equal to PF upon PR. Therefore, EF is parallel to QR. This is based on a result which we have studied in an illustration where if ABC is a triangle and E and F are the points on sides AB and AC respectively, then the ratio of the sides of these two similar triangles is equal. That is AE upon AB is equal to EF upon AC. Now this sum can be done in two different methods. Now we know that PQ is equal to PE plus EQ. So 1.28 is equal to 0.18 plus EQ. So EQ we get as 1.1. Similarly, PR is equal to PF upon plus FR. So 2.56 is equal to 0.36 plus FR. So 2.56 minus 0.386 is equal to FR. So FR is equal to 2.2. PE upon EQ is equal to 0.18 upon 1.1 is equal to 0.16. PF upon FR is equal to 0.36 upon 2.2 is equal to 0.16. Therefore, PE upon EQ is equal to PF upon FR. Therefore, EF is parallel to QR according to theorem 6.2. Now let us see question number 3, where we have to prove that AM upon AB is equal to AN upon AD. Now we have two triangles ABC and ADC. Now in triangle ABC, it is given that LM is parallel to BC. Therefore, according to theorem 6.1, AN upon MB is equal to LN upon LC. Similarly, in triangle ACD, AN upon ND will be equal to AL upon CN because here line LN is parallel to CD. This is given to us. Now from result 1 and 2, we can say that AM upon MB is equal to AN upon NB. Now if we apply the law of invertendo to the above equation, we get MB upon AM is equal to ND upon AN. Now applying law of componendo, that is adding a component 1 to the given number, that is MB upon AN plus 1 is equal to ND upon AN plus 1. We get MB plus AM upon AM is equal to ND plus AN upon AN. Now we know that MB plus AM is equal to AB upon AM. Same way, this is AD upon AN. If I apply the law of invertendo again, we obtain the required result. AB is equal to AN upon AD. This is our required result. Hence it is proved. Now let us do the fourth question. In the given figure, we have a triangle A, B, C again, and we have DE is parallel to AC, and we have DF is parallel to AE. We have to prove that BF upon FE is equal to BE upon EC. That is BF upon FC is equal to BE upon EC. Now, if we look at the two triangles which are formed here, the first triangle, that is in triangle ABC, DE is parallel to AC. Therefore, BE upon EC is equal to BD upon AD. And in triangle ABE, BF is parallel to AE. Therefore, BF upon EC is equal to BD upon AD. This is according to theorem 6.1. Now from result 1 and from result 2, we can say that BE upon EC is equal to BF upon EC. To make a bit of correction here, this BF upon EF. Upon FE. So we can say FE. Now if we go back to our result, we get BF upon FE is equal to BE upon EC. This is our required result. Now let us go to the fifth question. In figure 6.20, we have again a triangle PQR and EF is a line. You have a point O and D here. This is the given figure. Now they have told us that DE is parallel to QO or OQ. Same way, DF is parallel to OR. Now we have to show that EF is parallel to QR. Now if we take triangle PQO, triangle PQO, we know that DE is parallel to QO in this triangle. Therefore, PE upon EQ will be equal to DP upon DO. Similarly, in triangle POR, DF is parallel to OR. Therefore, PD upon DO is equal to PF upon OR. Sorry. Is parallel to FR. Now from result 1 and 2, we have PE upon EQ is equal to DF upon FR. Now from this result, therefore EF is parallel to QR according to theorem 6.2. Hence, it is proved. Thank you.